In this video, we're going to look at the rhombus, how to find the area, and some related problems. So a rhombus is a parallelogram with all sides the same length, kind of like a square. All sides are the same length. And if I draw the diagonals here, this corner to this corner is the diagonal D1, and over here, the lower corner to the top corner here, we have diagonal D2, D sub 2. And the important thing to note here is that the diagonals of a rhombus intersect at right angles. So this angle right here is right angle, this angle over here is a right angle, this angle here is a right angle, this angle here is a right angle. So those are things to know. We also need to know that the diagonals bisect each other. So D1 goes from this corner to this corner. So this segment right there is congruent or equal to this one over here. And on the other way, this segment right here is congruent to this one. Also, it's important to note that the diagonals form 1, 2, 3, 4 congruent right triangles. So here's one triangle here, and there's another one over here, there, this one here, and of course this one over here. And the area of the rhombus is given by this right here. Area of a rhombus is the product of the two diagonals, whatever the lengths are of the two diagonals, divided by 2. So we'll go back to this one over here. If we say D1 is equal to 7, and the length of diagonal D sub 2 is equal to 10, and the area of that rhombus will be 1/2 the product of those two diagonals. So 10 times 7 is 70, 1/2 of that, or divide by 2, you get 35. So the area of that particular rhombus is 35 square units. Now let's suppose we have another rhombus here, and it's rhombus, say A, B, C, and D. Unless we have one diagonal here, and a diagonal going this way. And suppose we're given that this side here has a length of 10. So obviously we know then they're all 10. And let's say BD is equal to 12. And these are not to scale, okay? So this is diagonal here, whether it's D1, D2, it doesn't matter. You can call it whatever you want. I'm just going to say BD. BD is 12. So in order to find the area, so we're going to find the area here. Obviously, like in the first one, if they give you the length of the diagonals, you just multiply them and take half of that, divide by 2, and that's your area. Now here we're only given 1, so this is length of 12. So actually this side right here is 6, and this side over here is 6. Now I need to find an AC. I know the length of BD to be 12, and I need the length of AC. Remember, these are right triangles here. So I got a right triangle right here. A, this point here to B. So let's call this Y right here. So if I can find Y, the value of Y, that's this segment from A to this intersection point. I just double that, and that gives me AC, which would be the second diagonal. So again, right triangle, Pythagorean theorem. So we take the hypotenuse, which is B right here, so it'd be 10 squared. 10 squared should equal to the sum of the squares of the legs of this triangle, which are 6 and Y. So this would be Y squared here, plus 6 squared. So this would be 10 squared is 100. Then 6 squared is 36. Subtract 36 from both sides. 100 minus 36 is 64. These cancel out over here. So I get Y squared is equal to 64. Take the square root of both sides. I'm only interested in positive numbers here because we're dealing with lengths here. So the square root of Y squared would be Y. The square root of 16 would be 8. The square root of 64, I should say, would be 8. So now I know the diagonals. So call them whatever you want, D1, and then it's given to be, that was given to be 12. And then the other one, this Y is only half of the diagonal AC, or D2, just what I'm going to call it. So just double it. That's 16. So those are the two diagonals. So then to compute the area, the formula then is A is 1/2 the product of the two diagonals, 12 and 16. And you can multiply each, either the 12 or the 16, doesn't matter which one. So let's say 1/2 of 12 is 6, and then 6 times 16 is 96. So the area is 96 square units. So let's say we have a rhombus, and every side of the rhombus is 6 units. Again, a rhombus is a parallelogram, all sides the same length, kind of like a square. We know the diagonals bisect each other and at the same time are perpendicular. And we're given this angle to be 46 degrees. That's 46 degrees. Now in some of these problems, you can get away without using trig, using the Pythagorean theorem. In some cases you can't. So what I'm going to do is draw the diagonals here. I got one diagonal this way, one diagonal this way. So this angle here is 46 degrees. This is 46 degrees. But when we draw this diagonal like this, it actually bisects that angle. So this angle here becomes 23 degrees. Now, a couple of ways to do this. I could find these are congruent triangles. So I could find the area of one of these triangles. Doesn't matter which one because they're congruent. They have the same area. Find the area of one of them, then multiply it by 4, and you got the area of the rhombus. So what I'm going to do is this, first of all, call this X, and I'm going to call this Y. I'm going to do it two ways. I'm going to first find X by using the fact that when I have it right, and again remember this is a right triangle, this is the right angle right here. 6 is the hypotenuse. So I'm going to use here to say I want the opposite over the hypotenuse. So this one would be then the sine of 23 degrees. Should equal to the opposite side, which is X, over the hypotenuse, which is 6. Multiply both sides by 6 here. So these cancel out here. So this would tell me then that X is equal to 6 times the sine of 23 degrees. Then I compute this out. Now make sure your calculator is in degree mode. So 6 times the sine of 23 degrees is 2.34. That's just units. That's not degrees here. That's just units. 2.34. Then I'm going to compute Y here using this triangle right here. Your 90 degree angle is right here. So I'm going to say this angle again here corresponds to that one over there. So that's the sine. So I'm going to say the sine, or I'm sorry, it's going to be cosine because it's the adjacent over the opposite. So it's going to be the cosine of 23 degrees. So it's going to be Y over 6. So you can see pretty much the same sort of setup, except instead of sine, I'm using cosine. Again, multiplying through by 6. The 6 will cancel on this side, and over here it'll be 6 times the cosine of 23 degrees. Again, make sure your calculator is in degree mode, otherwise you're not going to get the right answer. And then just go 6 times cosine of 23 degrees. Rounded it out to two places is 5.52. So now I know X and I know Y. So I know the base is Y. I call it. If I use the triangle here on the left, I can use the Y as the base, and the other one would be the height, the X. So for the area, notice we're finding the area of a rhombus, but we're using the area for the formula for the area of a triangle, 1/2 the base times the height. So here's what we do then. Get the calculator. So the area is going to be 1/2, I'm going to say 0.5, and it's going to be the product of these two bit numbers, One will be the base, one will be the altitude. So this will be 2.34 times 5.52. Hit enter. So this gives me the area of one of these triangles. And remember, they're all congruent. They're the same size and everything, so they have the same area. I have 4 of them, so just multiply this by 4 times 4. So I can say then, so I messed up my screen here. But anyway, it's multiply this by 4, so this will be times 4. And I already did it. So all I need to do here is the area then is this right here, to 1 decimal place, 25. I'll leave it to 2 places. I did the others to 2 places, 25.83. And that's the area. The other way I was going to do it, which is a little bit longer, but it's the same. Now I have the information that I need. I have the segments that form the diagonals. So this 2.34, double it, I get one of the diagonals. And this 5.52, double it, I get the other diagonal. So just to make it a little bit shorter here, let's do this. So it's the product of the diagonals. Let's do it this way. 2.34 is half of one of the diagonals, so double it. Okay, so that's one diagonal. Call it D1 or D2, whatever. And then the other one is 5.52. That's half of the other one. Double it to get the whole diagonal. We multiply these and then take half of it. Okay, so let me just do this. Multiply them. We get 51.6672 and so on. And then we divide that by 2. Because the formula is similar to the area of a triangle, but it's 1/2 the product of the diagonals. So I'm going to divide this by 2. So divide this by 2. And I still get the same answer using the 4 triangles, 3. Okay, thanks for watching. We'll see you next time.